All right, so some little pieces about our polynomial graphs, okay? So we know how to find zeros from a function, doing synthetic division, finding those zeros, graphing them. I never actually made you graph them, right? We just found them and we solved for it. So now we're going to look at my graphs. Lots of things are come from our graphs, okay? First thing we're going to look at is degrees and terms, okay? Then that's going to link us into end behavior. So they are all linked together, right? So looking at this, to find the degree of a function, if I just give you the graph, you count your terms and you add 1 to it. Okay, think about it. That first one is what kind of a graph? Parabola. It's a parabola. We've done these. And they always had a degree of what? 2 every time. How many turns are there? There's 1 turn. There's 1 place where my direction changes. This is a degree of 2. So it makes sense. You know that's a parabola, okay? So we take our turns, we count them. A turn is when I change direction from up to down or down to up, okay? And we add 1 to it to get my degree, all right? How about this next one? How many turns are there? 3. 1, 2, 3 turns. So my degree is beautiful. Turns with an N. All right, how about the last one on the top row? 2 turns. So my degree is trace. All right, so these were very basic graphs up here. Degree of 1, degree of 2, 3, and 4 are pretty basic. Down here, they get a little crazy. All right, but you can still do it. How many turns? 1, 2, 3, 4, 5 turns. So my degree is 6. Good. And then that last one, how many turns? 4 turns. So my degree is 5. Okay, it's +1 every time. And then so if I went backwards, if I gave you the degree and asked you to sketch the graph, which I'm going to, you would just subtract 1, and you know that's how many turns you'll have on the graph. Okay, so it goes both ways. All right, let's look at these graphs a little bit more. Okay, because we said it links to my end behavior. End behavior is how your ends behave, right? Your ends are either going up or going down. Okay, I want you to look at the 3 over here on the left-hand side. So I want you to look at this one, and this one. I want you to look at their graphs. Okay? What's even? Okay, so the degree number was even, 2, 4, 6. All right, is there anything else they have in common? What are you seeing?
They're both going up.
Okay.
Opening up.
My ends are both going up. More importantly, they're going the same direction. Okay? So that might mean something for us. Maybe. Let's see. So if you think an even degree means they go the same way, what do you think an odd degree is going to give us?
Opposite way.
Okay. Was that true?
Yeah.
Look at that. Up and then down. And then up here we had down and then up. Okay. So our degree also helps me with end behavior. Okay. There are 2 things we're going to look at. One of them is our degree, okay? The other piece is going to be our leading coefficient, okay? Leading coefficient, where do we find that? Yeah, it's my first term. It's in the beginning if we're in standard form, right? So it's the piece with the highest exponent. If that number is positive, okay, if it's a positive leading coefficient, my graph will always end up in the positive direction. Okay, regardless of what the other one is doing, it always ends up in the positive direction. If our leading coefficient is negative, down here, notice these always end up in the negative direction. Okay. So we're looking at leading coefficient. Is it positive? Is it negative? And then we're also looking at our degree. Is it odd or is it even? All right. So if it's an even degree and I have a positive leading coefficient, I know both of my ends will go in the positive direction. If it's even with a negative leading coefficient, both of my ends will go in the negative direction. Okay? It doesn't matter how many turns happen in the middle. If it's just one, that is ugly, I'm sorry. Or if there's a bunch, Okay? If there's more than one, we care about what the ends look like. I'm just kind of recreating that little graph that's in front of you a little bit. It's a little bit different. Okay? Odd means opposite. Okay? Odd, opposite. They're going to go in opposite directions. The leading coefficient tells you how it ends. So a positive leading coefficient means I end up positive. So to be odd meant I started negative with whatever terms happen in the middle. And then negative is opposite. We're going to end up being negative, but we'll start positive with however many turns along the way. Okay? So I don't care about the terms in the middle right now. We're just looking at the end behavior. Okay? There's a way we write end behavior, as you can see written in our chart. We always have as x goes negative and as x goes positive, okay? That will always be the same. What you fill in is where the graph is actually going, okay? So you fill in these pieces. These are the only pieces that will change each time, okay? Where your graph is going. So on the board, what's in black, that will never change. You will always have as x goes negative. You will always have as x goes positive. Because as x goes negative, that's just saying the left side. As x goes positive, that's just saying the right side. Some teachers just say up and down. I don't do that. I think you're smart enough and you can handle the infinities. Okay? If I'm going to say up, I'm going to say what? Positive infinity. If I'm going to say down, we're going to say negative infinity. Look at that. Smart kids. Okay? But that is the piece that will change each time. Okay? What is nice, my even degrees, they'll always be both positive or both negative, right? So these would always be you would always match it. And then our odds, we do see what comes first and what comes second. So you would do what? So as x goes negative infinity, this is where you're starting. And then as x goes to positive infinity, that's where you're ending. Okay? Because we always read left to right on our graphs. We always read left to right. Our numbers always go negative to positive. Okay? So looking at the left side, looking at the right side, what is it doing? So if I was doing this first guy right here, you would start off with what? With negative infinity. I'm going to do my pink. We would start with negative and end up positive. Both of these are positive, right? Here, start positive, end up negative. Here, they're both negative. I don't think that piece is written in your chart. I would write that on the ends of your graphs for yours. I'll do it in blue. So I would put that on here. Like this is negative, this is positive. These are both positive. Start positive and negative. These are both negative. Okay. So again, what's written in black up here is what will never change. That will always be there because you will always have a left and right side. You're going to fill in what the graph is actually doing. Is it going up or is it going down? Okay? What's up?
Okay, the first one.
Yep.
I don't know how to put this. Is it because it's going positive, negative.
Mm-hmm.
It's
Are you talking about this positive?
yes, the first.
Okay.
The first
So that is always showing you where it ends up.
So then why did it go to negative?
Because the first one had an odd degree. So odd means opposite. So the ends were opposite.
Oh.
But to have a positive leading coefficient means that it ends up going in the positive direction. Down here, my negatives, notice they end going in the negative direction. But the even or odd degree tells you if the other side is opposite or the same.
Okay. I'll do it eventually.
I think once we do some problems, it'll click for you. Let me know, though, if it doesn't, okay? So the front is like all your information. The back is going to be our practice problems. All right, so we're going to do it a couple different ways. The first way, I'm giving you a polynomial in standard form. Then I'm going to give you a graph. Then I give you a polynomial in factored form. Okay, and that's where we're going to get back into multiplicities and stuff. All right, we're going to bring it all together. All right, this first one. Negative x to the fourth plus 6x cubed minus x plus 9. All right. Again, we only care about the leading coefficient and the degree. Those can both be found the very first term. If we're in standard form, which these are, the first term gives you both of those pieces of information. So the plus 6x cubed minus x plus 9, it's nice, but it's not needed for what we're doing. Okay? I'm not asking you to solve for the zeros like I did before. We already did that. So according to this, what is the leading coefficient? It's a -1, which is a negative number, right? So when I go to sketch my graph, I'm going to end up in the negative direction. That's where we're going to end our graph. You got little blanks on this side, so just pick one for this graph, and we'll pick the other side for your graph. Okay, to know what the first part is doing, I have to know the degree. What is my degree? It's a 4, and is that an even or odd number? Even. So what does that mean about the other side? Even means the same. Odd, opposite. So OO, even, same. I had nothing fun for that one. Sorry. There's two E's in even. They're the same letter, so they're going to go the same direction. I got nothing fun. Sorry. I just got odd, opposite.
S.
Okay. S. That doesn't work for degree or even. All right. So if I go to sketch this, okay, how many turns will I put in between it? There's going to be 3 turns. We're going to have 3 turns. So I'm going to change direction 1, 2, 3 times. It would look something like that, like the McDonald's arches. Okay? So it's changing directions 3 different times. This is a rough sketch. Okay? All right, in behavior. Okay? So again, this black piece is never going to change. Okay? That black piece never changes. Okay? Since they are the same, they're both going the same way. Where are they both going? They're both going down to negative infinity. And that's your in behavior. So the black piece never changes. The blue piece is what you have to actually look at the graph to find. How was that?
Not bad.
Yeah. Okay. I'll take not bad. I'll take it for now. All right. Let's go to our next one. 2x to the 5th plus 6x squared, to the 4th, minus x plus 4. Standard form, which piece do I care about? Just the 2x to the 5th. My first term will give me my leading coefficient and my degree. Okay? What is my leading coefficient? Just a 2, and that is a positive number. So what does that already tell me about my graph?
It's going to end going up.
It's going to end up going in the positive direction. Yes. All right, what is the degree?
5.
It is 5. That is odd. So what does that tell you about the other end?
It's going the opposite direction.
It'll be the opposite direction. Okay. So I do the little arrows first. Now I gotta fill in the middle. How many turns? You had it? Yep, 4. There's 4 turns for this one. So change direction 4 times. 1, 2, 3, 4. Something like that.
1.
So 1, 2, 3, 4 different spots where it changed direction, right? And yours probably looks different than mine. That's okay. So that means you have 2 peaks and 2 dips, right? If we have 4 turns, we have 2 and 2. All right, in behavior. So this is where my x's are going negative. This is where my x's are going positive. I want to know what are the y's doing. So if my x's are getting smaller, means we're looking on the left side. Where are my y's going? Are they going up or down? They're also going down. All right? And then my other side, the right side, when my x's get bigger, where are my y's going? And how do I say bigger in math? Infinity. Good.
So we can just look at the starting point and be like, oh.
Yep, absolutely. All right, so how do we feel about coming from standard form?
Pretty good.
Feel okay?
No.
We're going to do factored form.
Yeah, I hate this.
We'll do factored form, yeah. It's not as bad as you think it is. All right. Now let's go from a graph, though. Let's go from a graph. Okay. From a graph. Here, it just wants to know leading coefficient and degree. Okay. Is it positive, negative? Is it odd or even? That's all it wants to know. Okay. So, looking at this, my leading coefficient matches what the end is doing. So my leading coefficient is a negative something. We don't know what it is, but we just know it's negative. Our degree, since my ends are opposite, it's going to be an odd number. Yep.
Oh, it's gonna be.
What is that number? Yeah, what is it?
1,
Is she...
4. No.
Okay, does it make sense to say 4? You got to add 1 to it. Yes, because my degree is 5. You good?
Yes.
You want to try the next one?
Yeah.
It's negative. No. We're not doing that. Nope. We don't. We could, but we're not.
No, we're not going to do that. That's gonna make it.
We're not doing that. So just this next one. Leading coefficient, you should just have positive or negative there. And then degree. So do this one. Compare with the neighbor. I'll give you a whole 5 seconds. All right, Kaylee. Leading coefficient, did you say positive or negative? Positive. Adam Z, why did she say positive? Yes, good. Last one's going up. Beautiful. Aaron, what'd you put for degree? Even. Langston, why did she say that? Because they are both going up, right? Not just because it's going up, it's because they're both going the same direction, right? So same direction. What's another way to figure that out, Emily?
To figure out what?
That it's an even number. He said because they were both going the same way. What's another way to figure out that it's an even number? Adam, what do you think?
You can count up the thingies and then add 1 to it.
Okay, so count up the turns. There's 3 turns. Add 1 to that. My degree is 4, which is an even number. There's a couple ways to get your degree. Okay.
This is fun.
You like it so far? Have we done worse things in this class?
Yes.
Just last week, right?
Yeah.
Alright, we're almost done. We're almost there. Alright, last two. Alright, so this time I'm giving it to you in factored form. And I am linking what we did last week into this. So zeros and multiplicity. Not new things. You know them. You know them. Okay? So if I give you x times x minus 3 times x plus 5, what are the zeros? 0, 3, and negative 5. Good. You put each piece equal to 0 and solved for x. Okay? The multiplicity. Where did we look to find that? Each of their little exponents. And now they're not written, but what do they all have? They all have a little 1 right there. So they all have a multiplicity of 1. Okay? Alright, leading coefficient. That's still the first piece right here. It is positive. It's a 1. Yep, it's positive 1. Okay. Degree. Add up your multiplicities. What is 1 plus 1 plus 1?
3.
So your degree is 3, which is an odd number. Add up your multiplicities. When you, we're not doing turns yet. We will do turns, but just to get what my degree is, looking at this, I can add up my multiplicities together.
So it's going to start
When I go to graph it, yep.
It's going to start as a negative.
Yeah. So we know it's going to have how many turns when I graph it?
4.
It's going to have 2 turns when I graph it. Okay? Degree minus 1 gives you the turns. All right. So this time, y'all, stay with me. Stay with me. This time when I graph, I know we're going to end up in the positive. We know it's opposite, so I start negative. But this time when I go to draw it, there are 3 other specific things I need to have. I need to have an x of 0, an x of 3, and an x of negative 5. So I got to make sure when I draw my turns, they cut through that part, because we know my x-intercepts. Okay? So when I cut through, we're going to cut through this guy, turn, cut through this guy, turn, and cut through this guy. Hey, look at that, 2 turns. And I don't care how high or low your turns are. That doesn't matter right now. We could find your max and min, but we're not. Okay? Like how tall the turns actually go. That's up to you guys. We're not gonna actually find that. Okay? Yeah.
Let's keep it simple.
I'm trying to keep it simple. As simple as I can. Questions on that one? Alright, how is this next one a little bit different? My A is negative. And there's a multiplicity of 2 showing up. So let's see how that changes what we do. Alright? So, negative x times x plus 2 squared times x plus 4. So what are the zeros going to be?
0, -2, -4.
Good. What is the multiplicity when x equals 0?
1, 2, 1.
The multiplicity when x equals negative 2. That was right here, yep. And then 1. Good. So, yeah, you're right. Let's start with leading coefficient. Is that positive or negative?
Negative.
Negative. How do you know that? Because there's literally a negative in the very beginning. Okay? So yes, it is negative. So we know we're going to end my graph in the negative direction down here. Okay? What is the degree? My degree is 4. 1 plus 2 plus 1 is 4. So that means it's an even number. So what do I know about the other side? It's going to be the same. It's going to match it. It's going to be the same. All right, now we got to go through 0, -2, and -4. I'm going to move this guy a little bit closer, like that. Okay. All right, so there's 3 turns, right? So what happens if I just do this?
You're wrong.
Uh-oh.
That doesn't work.
Can I just, like, turn it and come back down? No, because I don't have any other x-intercepts.
You do that too, like the
Oh, you have to
value.
go. 1. Wait, 1, 2, 1, 2.
What does a multiplicity of 2 look like? It's going to touch it. Good. It's just going to touch it and bounce away. Watch. Watch. So what's happening where? -2, right? So we're still cutting through to 4. We're going to bounce off of 2. Oh. Remember when our vertex for parabolas was one double root and it just touched it one time? That's what this is. Okay?
If you cross the axis, right? That's fine, right?
Yeah. Okay. So, when we have a multiplicity of 1, okay, we're going to cut through our x-axis. Okay? It just cuts straight through it, nothing fancy, a normal graph. Excuse me. If there's a multiplicity of 2, that is when, y'all listen, that's when we bounce off of it, okay? So this right here would be my multiplicity of 2, okay? We're going to get to multiplicity of 3 in a second. It happens on your homework, so don't do your homework yet, please. It happens on your homework, okay? Don't do it yet. Questions for me so far? All right, here we go. Fix it if it needs fixing. All right, you're checking it with me. The zeros, they should have 6, -1, and 3/2. Or 1.5, same thing. Multiplicities are 2, 2, and 1. Our leading coefficient is positive. Our degree is odd. It's actually the number 5. Which means we should have 4 turns, right? Little note to self. We should have 4 turns happening. All right, let's see. So we're crossing at, go back. We're crossing at 6, -1, and about 1.5 is right here. It's positive, so we're going to end up in the positive direction. It was odd, right? So we start in the opposite direction. -1 and 6 have that multiplicity of 2. So we're bouncing, cut, bounce. Something like that. So check it, fix it, give it back. Check it, fix it, and give it back to them. Huh? Is what?
Is any other, like, I did it different ways. Is that wrong? Like, I did up and then I bounced off of 1.5.
It has to bounce off of -1 and 6. Because they have the multiplicity of 2. Alright, fix it, pass it back. Alright, there is one last thing that we need to check. Awful. Alright, so, it's called a wiggle, yes. So a multiplicity of 3, it will not happen a lot, but it does happen in your homework. It happens on number 3, actually. If you look at number 3 on your homework, see how when x is equal to 2, it kind of curves in and curves out of it, okay? That's a multiplicity of 3, and that counts as 2 turns, because it turns in and turns out, okay? So it looks something like this. So it does happen on your homework, okay? It may or may not pop up again. Who knows? But you do need to know what the multiplicity of 3 looks like. We do work with 1 and 2 most often. Okay? So 1 cut straight through. That's normal. 2 is going to bounce off. And then a multiplicity of 3 is going to curve in and curve out of that point. Okay? So I'll leave this up as you're working. Your worksheet, there are 13 problems. The first 8, I give you the graph. I'm asking you what are the zeros. I want the multiplicity of each 0. Okay, so write it above it or below it. But I need x equals this, this, and this. And then above or below it, give me their each multiplicity. All right? I want your leading coefficient. Is it positive, negative? What is your degree? You can give me the number because you can count your terms, right? You can also add up your multiplicities. There's 2 ways to get your degree, right? And then in behavior, again, the black piece on the board right now, that black part does not change. So all of your in behaviors start that way. Okay? You fill in what your graph is actually doing. All right? On the back, I give you factored form, okay, like the ones we just did. And then the very last one, I tell you about x-intercepts and multiplicities, and you have to draw it. You will all have something different because I don't tell you what leading coefficient is. So you choose whether or not you want it to be positive or negative. I don't care. You're all going to have different ones for 13. All right? So work on this until the bell. If you get it done, you probably won't. It's due Thursday. I'm not going to see you tomorrow. All right? So you do have until Thursday to work on this.
You're aware.